Welcome to Daily Papers, the podcast where we break down fascinating new research into bite-sized conversations.
Today, we're talking about something you've probably experienced if you've ever used an AI chatbot like ChatGPT. You ask it a question, and it gives you a beautifully written, confident-sounding answer that is completely and utterly wrong.
Right, it's a phenomenon that researchers call hallucinations. The AI isn't seeing pink elephants, it's just generating statements that are plausible but have no basis in fact. And this can be a huge problem. If you're just asking for a poem about your cat, it's funny. But if you're asking for medical or legal information, it can be genuinely dangerous.
Exactly. So how do we fix this? How do we build AI we can actually trust? That's the question tackled in a new paper from the University of Canterbury, New Zealand. It's called KEA Explain, Explanations of Hallucinations Using Graph Kernel Analysis by Reilly, Haskins, and Benjamin Adams.
That's a mouthful of a title, but the core idea is brilliant. They've built a system that doesn't just detect when an AI is hallucinating, it also explains why the statement is wrong in plain English.
So how does it work? The secret sauce involves something called a knowledge graph. The best way to think of a knowledge graph is like a mind map or a spider diagram of facts.
Okay, so if the fact is Paris is the capital of France, you'd have a bubble for Paris, a bubble for France, and a line connecting them labeled is the capital of.
Precisely. So the first step in this KEA Explain system is to take the AI's output, the sentence it generated, and turn it into one of these mind maps. Let's call this the claim graph. The paper gives an example where an LLM claims John Russell Reynolds was an English lawyer, judge, and author. KEA turns this into a little web of facts.
So you have a bubble for John Russell Reynolds connected to bubbles for lawyer, judge, and author, but that's only half the story. How does it know if that's true or not?
This is the clever part. The system then goes to a trusted source of facts like Wikidata, which is a massive free knowledge base. It looks up John Russell Reynolds and builds a second mind map based on what it finds there. Let's call this the truth graph.
And I'm guessing the truth graph for John Russell Reynolds looks a bit different.
It does. The real John Russell Reynolds was a physician, not a lawyer. So now the system has two different mind maps, the claim graph from the AI and the truth graph from the real world. The next step is to compare them.
How do you compare two mind maps? You can't just overlay them, can you?
You can't, and this is where the graph kernel analysis from the title comes in. A graph kernel is a fancy mathematical tool that essentially measures the structural similarity between two graphs. It looks at the nodes, the connections, and the overall shape to produce a similarity score.
So it's like a structural spell checker for facts. If the two mind maps are too different, the system flags it as a potential hallucination.
Exactly. A low similarity score means something is fishy. But this is where KEA Explain goes one step further than a lot of other systems. It doesn't just say error, fact not found.
This is the explain part of the name.
Right. The system looks at the two graphs and pinpoints the exact conflicts. It sees that the claim graph has a connection, occupation, to lawyer, while the truth graph has occupation to physician. It identifies these specific contradictions.
And then it tells you about them.
It does. It feeds these contradictions to another LLM and asks it to generate a clear human-readable explanation. The final output might be something like, the statement is a hallucination because it claims John Russell Reynolds was a lawyer, but factual records show he was a physician.
That is so much more useful. It's the difference between a calculator just saying error and it saying error, you tried to divide by 0. It helps you understand the mistake. The authors call this a neurosymbolic framework, which is just a way of saying they're combining the best of two AI worlds.
Yep. You have the neuro part, the large language models that are great at understanding and generating text. And you have the symbolic part, the knowledge graphs, which are all about structured, logical facts. It's like pairing a creative writer with a meticulous fact checker.
So, did it work? How does it stack up against other methods?
It performs really well. The researchers tested it on two types of problems. The first is closed domain, where the AI has to answer questions based on a specific text you give it, like summarizing a news article. KEA Explain was very competitive with the top methods out there.
And the second type?
The second is open domain, which is general knowledge, like our John Russell Reynolds example. Here, it was especially good at catching hallucinations when they happened. It had a very high recall, meaning it rarely let a falsehood slip by.
That sounds great. Is there a catch?
A small one. The results suggest that in its effort to catch every mistake, it can sometimes be a bit too cautious and flag things that are actually correct. It has lower precision, but the authors argue that for high-stakes information, you'd rather have an AI that's a bit too careful than one that's confidently wrong.
That makes total sense. I'd rather my AI fact checker double-check something that's right than let a dangerous piece of misinformation through. The most exciting part for me is the quality of the explanations themselves.
They tested that too. They found that the explanations were clearest and most detailed for the biggest, most obvious hallucinations. When the AI's mistake was more subtle, the explanation was a bit less detailed, but still helpful.
Ultimately, this feels like a really important step forward. We're not just trying to make AI more accurate, we're trying to make it more transparent and trustworthy. Being able to explain its mistakes is a massive part of that.
I agree. It's about building a partnership with AI where we can question it and it can show its work. This paper provides a powerful and practical framework for getting us closer to that goal.
A great paper showing how we can get AI to not just admit its mistakes, but learn from them. That's all the time we have for today.
Thanks for tuning in to Daily Papers.